Good morning, everyone, and welcome to the CBER Forum for today. We're very pleased to have with us Ellie Ben-Sasson who is a chief CEO and co-founder of Starkware, and before that was still a renowned computer scientist, but he was affiliated with Technion University. And if you have questions during the talk, please put them in the Q&A, and we will feed them to Eli. All right, Eli, welcome, and go ahead and start when you're ready.
Thank you, Joel. I just would like to ask, for how long should I be talking and for how long should I be answering questions?
Well, we have a hard stop at 12:15, but if let me ask you, would you prefer to take questions during, or everybody save them up, including clarifying questions, until the very end?
I definitely prefer to answer questions on the fly.
Good.
And
All right.
I would prefer, I think I have a hard stop at the hour at noon, so I don't know if that's
That's
fine.
fine. Yes.
Okay, terrific.
Good.
Yeah.
Please, whenever you're ready.
Okay, so I'm going to share my screen, and I would definitely prefer to have people. Let me just bring this up. Okay, let me do slideshow, and I'm sharing my screen. No, okay.
And
Can you
now we can
see it?
see it.
Okay, ZK Starks solve the blockchain trilemma. Okay, so let's start. First of all, nice to meet you. A little bit about myself. As Joel said, I used to be a professor, a full-time, full professor at the Technion CS department. I did academic research, I think starting in the 90s till I left to co-found Starkware in 2018, about 7 years ago. I'm very proud of co-inventing both ZK Starks that I'll tell you a little bit about and the Zero Cash protocol, a little bit of the stuff that I did. So I started getting into implementing code related to ZK cryptographic proofs already in 2008. In 2013, I had my eureka moment of understanding that what I'm doing has relevance to blockchain. And I was also the very first to realize that the scale problem of blockchain can be solved in the best way with this technology. This happened at a conference about Bitcoin in San Jose in 2013, where I gave a talk there. And ever since then, my career has veered towards blockchain. So I was one of the co-authors of the Zero Cash paper, and we founded Zcash based on it. That was in 2016. Continued doing more research on math that leads to better cryptographic systems, which in 2018 led to a few breakthroughs that set the ground for Starks. And I co-founded Starkware back then. Our first product came out 2 years later. It was a scalability layer for Ethereum called StarkX. And in 2021, we opened the layer 2 called StarkNet. And by now, the technology I co-invented is pretty much widely adopted as the end game scaling solution for all, at least Ethereum L2s. So if you heard of other projects that are doing things called ZK rollups, they're pretty much nearly every one of them is using Starks as their main scaling engine. Starkware, the company I lead, at its latest round was valued at $8 billion. We've settled over $1.3 trillion in cumulative trading over Ethereum. And currently, we're just over 200 employees. We service such companies as DYDX, Paradox, Immutable, Sorare. And now a whole lot of applications on top of Starknet, which is a layer two, on top of Ethereum, which is also going to join and scale Bitcoin very soon. We come from a highly pedigreed academic world, and we have a lot of illustrious academic advisors. In this list, you have Shafi Goldwasser, a scientific advisor, um, the recipient of the Nobel, not the Nobel, sorry, but almost the same thing, Turing Award 2012 for inventing ZK, along with Silvio Micali. Avi Vigdorzon was my PhD thesis advisor, and he received the Turing Award last year. I think Noam Nissan has a good chance of getting a Nobel Prize for launching algorithmic uh, game theory, and a lot of others. So, but what I really want to start talking about is before I get to where we fit in and where ZK helps solve blockchains, scaling trilemma, I want to share with you what I view as Satoshi's innovation, right? Satoshi Nakamoto, the pseudonymous name of the inventor of Bitcoin. So Bitcoin is many things and many different things to different people. I would like to share with you what I think is the core innovation of Bitcoin. And the reason that I think this could be important for you and why you should care about it is that there are a lot of blockchains out there. And frankly, not a single one of them, including Bitcoin, has so far found real global product market fit. Not yet. Okay. So when I say real global product market fit, I'm thinking about something like the internet, or what Google call the toothbrush test, which means something is useful if you use it twice a day and find value in it. And I think for most of the world, Bitcoin is not a toothbrush. You don't use it twice a day and find value in it. There's a very small number of people that use any kind of blockchain today. So we have to realize that blockchain, for all of the hype and all of the interest in it, and I'm certainly a big fan, doesn't have product market fit yet. And if you're going to choose to build on something or work on something, you're probably going to be limited to only one, just because it's a lot of work deploying and working on any one of these blockchains. And what you want to do is you want to avoid kind of a catastrophe where you chose the wrong infrastructure and the wrong blockchain, or you chose it for the wrong reasons, and you find out that as you try to reach global scale or really find real global product market fit, you fail. So it's really important to figure out what is it that makes blockchains tick. And I want to share with you what I think is the core innovation and how it is relevant. So I'm mentioning here three blockchains that a lot of people are talking about. So Bitcoin is often known as digital gold, or sometimes as resistance money, or something that's fully censorship resistance. Ethereum is known as the world computer, um, though as a computer it's pretty slow. So there are a variety of rollups that try to scale it. And then you have Solana, that goes under sort of the phrase of like decentralized Nasdaq. It offers Web3 infrastructure for all, but the caveat is you need to have a pretty large computer to understand what's going on there. It's something that basically is putting a lot of hardware to give higher performance. And you're gonna have to pick like which one of them you're gonna go with if you're gonna build anything. And I'm assuming a lot of people here are interested not just in learning the underpinnings of it, but also, you want to know which tribe you need to choose and go with. So I hope I can give you some insights to that. And before I get into what I view as the real thing that is blockchains, I think of it as the integrity web, or building an integrity web, which is something that will sit atop the World Wide Web. Um, so here's where I think blockchains or the integrity web fits in. So often you see that there's a new economic domain that's discovered. This happened a lot of times in history. And then there are some people who are very fast to figure out what is the core thing there. And they usually start by controlling it and exploiting it. And at some point, society fights back and says, wait a second, this isn't the right way to to deal with this economic domain. And then some new domain emerges. And of course, that happened with agrarian societies. It happened in the Industrial Revolution, and it's happening today. It's unfolding in the digital space, right? We have a few very, very large and powerful parties that have been resourceful at being there first and creating network effects. But now, what the integrity web or blockchain or Bitcoin is trying to do is basically saying, wait a second, we can make things a little bit more fair. We can turn the digital space into something that is a little bit more like a public, I mean, you're in Colombia, so something like Central Park, right? A public domain that it's not exploited by a very few number of companies. Okay, so first of all, what is the integrity web or what are these blockchains? I think of them as infrastructure for something that is very, very old. It is infrastructure for social constructs. And social constructs are very old things. As long as human societies have been around, then people have come up with all kinds of social constructs. Money is the prime example of a social construct. So, what is money or what are social contracts? These are protocols and registries and data sets whose value, they carry immense value. Again, think of money, but their value necessitates a very broad consensus about their integrity. So you need to have inherent integrity. Money needs to operate like you expect money to operate. Integrity, I like the definition of C.S. Lewis, which is integrity means doing the right thing even when no one is watching. So we have a certain perception of what money should have as its inherent integrity, that you shouldn't be able to mint an infinite amount of it, that if you have a certain amount of it, it doesn't disappear suddenly or it doesn't, multiply 10x. That if you have money, you can transfer it to anyone that you want, of your own volition, and so on and so forth. So there's the inherent integrity of money, but no less important is the perceived integrity of money, the social consensus that money is doing what money should do. And that's one example of a social construct. There are other social constructs like, marriage registries, academic titles, your um, reputation, your credit score, your credit history, your business dealings, your social network. All of these things carry immense value only if they operate with integrity. And also, additionally, there is consensus that they operate with integrity. But money is the prime example. So, what are these integrity webs, or what is the integrity web, and what is this thing that Bitcoin was the very first to uncover? It basically suggested a new way for creating infrastructure for social constructs. And Bitcoin did this first for money. And then Ethereum, I think, generalized it to to other kinds of social constructs. But really, we're talking about something that is in the domain of social sciences, economics, political theory, things like that. So there are three principles that are unique and novel to the way Bitcoin operates. Each one of them, you could ask whether it is something that also applies to conventional money, and you'll realize that the answer is no, it doesn't. And these three principles are broadness, incentivized integrity, and public verifiability. So let me explain what each one of them means. So broadness means that the way you base this infrastructure, Bitcoin as an infrastructure for a social construct such as money, the way you do it is to create a protocol that is broad, decentralized, open to all. Anyone and everyone is invited to operate a Bitcoin miner node. And in fact, part of the security of the protocol is that the more of us run these nodes, the better off the system is in terms of its integrity and its perceived integrity. So again, compare this to the way dollars are managed in the US in the conventional banking system. None of you is invited to operate part of the infrastructure that deals with money transfers, right? You're barred from it. You have to have special licenses to do so. And certainly the security of the system wouldn't increase the way it's operating today if you were offered to participate in operating the system of, dollar transfers. Okay, so that's one principle that is in stark contrast to the way the conventional system works. The second one, which is perhaps the most surprising and the deepest, is incentivized integrity, which says that the protocol defines a way to distribute value automatically to operators, right? And everyone is invited to be an operator. And the purpose, the reason for distributing value is to maintain this integrity, both inherent and perceived integrity. So take Bitcoin. If you operate a miner, you have a chance at getting new minted Bitcoins and you get rewards from operating Bitcoin. The reason you're given this is to incentivize you and all the rest of the world to operate with integrity, right? For there to be no double spends, no invalid transactions, to not rewrite history. The whole system is built so as to incentivize integrity, inherent and perceived. Again, compare this to the way dollars are managed, even in the digital world. None of the payment processors, Stripe or Visa or any of the banks don't offer you to be part of this broad network, and they certainly won't give you a portion of the fees in order for you to participate and validate transactions and offer new blocks, right? So this is a very ingenious way in which Satoshi solved the problem of infrastructure for the social construct of money. And the last aspect is public verifiability, which means that the integrity of the protocol itself and the very latest state of the registry, for instance, in Bitcoin, this would be the UTXO set. You can verify each and every transaction from the very start till the very latest block using public available means like a laptop and connection to the connectivity to the internet. Again, you and I are not invited to audit and review the transactions of NASDAQ or any payment system, right? So these three principles are, each one of them is completely surprising and novel. And when I heard of Bitcoin for the very first time, I didn't believe that you could have money operated in any way that isn't, the conventional way. And yet now we are. It's 16 years, I believe, since Bitcoin emerged. And these things do carry immense value and by many are perceived as a very good form of money. So the core innovation, just summarizing, of blockchains is not about hashing and cryptography or ZK. It is about a new way, a better way, I think, a new and fair way, a way that very much goes with freedom, with empowerment of individuals, a way for basing social constructs. And there are three principles underlying it: broadness, incentivized integrity, and public verifiability. And the reason I'm starting with this and sharing this with you is because, at least, I view, and we're heading Starknet to be part of this integrity web that connects different blockchains. And we want global society at large, with all of its social constructs, to run on such integrity webs on top of the World Wide Web. And what we bring to the table is using the integrity of math to expand the amount of integrity you can enforce on large operators without any trust assumptions about them. And this will be the second part of my talk. So, our mission is that integrity should never be assumed, but rather exhibited publicly and upheld by all. So the way, like, I imagine a world in which nation states and corporations, when they make guarantees to their customers or to the citizens, these guarantees will be converted into smart contracts, which means code. And this code will be executed on the integrity web in a way that any assertion made will be upheld not by the party that made this assertion or this guarantee, but it will be upheld by all. Just like, the guarantees that Uniswap, right, the marketplace, is making to its customers is not based on trust in Uniswap. It is based on smart contracts that are then enforced by a large decentralized network, in that case, Ethereum. So I believe, at least, that Starknet, which is a layer 2 on Ethereum and soon on Bitcoin, will rise and fall, not on its technical merits, the same applies to any other blockchain, but on its integrity and other values. And at least the way we're thinking about Starknet is as long-lasting public good. And the reason we want to do this is that so that you and not these big corporations or nation states own your digital life and through it own your life in a way that is more immediate and meaningful than the way things are done now, where you custody much of the things that are important in your life with big companies. Okay, the next part is like going a little bit into what are ZK Starks and how they solve the blockchain trilemma. But I can pause here for questions if there are any.
Anyone? Ellie, I don't think we have any questions in the Q&A, so that's a terrific introduction. Why don't you continue?
Okay. By the way, to me, lack of questions means I'm not doing a good job because it can't be that everyone understood and agrees with everything that I said. So I must be, not doing a good job. So I hope there are some questions. Please post them. Okay, Abdallah, yes, I would love to. How do I, Joel? How do I?
Let me see. I have one open question. I have one open question in the Q&A, but I do not. It's a really amazing introduction.
Okay, okay.
So, so
I saw that. I saw someone,
I
Abdallah
briefly
Tanzim.
I saw a raised hand too, but I'm not seeing that now.
Okay,
So, please.
Abdallah, if there's a question, please post it. And so thank you, Oriel.
And by the way, I don't think that you're it's a lack of interest and that was those were very provocative things to the point where many of us view them as idealistic and speculative, but certainly you have the floor to make your case further.
Okay, okay, terrific. Okay, so I would love more questions. Um, okay, here we go. I am going to share. Can you see this part two?
We're on.
Okay, so first of all, what is the value proposition of zero knowledge proofs? What, as a technology, what does it offer? So at the very core, it is a means to an end. People talk a lot about ZK proofs, which is something that I worked a lot about theoretically, and Starkware now implements, and a whole lot of other operators in the space deal with. But if you ask, do do I want to see a proof for something? The answer is no. And if I trust you, if you're my family, I actually don't need any proof for your assertions because a proof is a means to an end. And the end is integrity. It is knowing that the right thing is done when I was not watching. So if I have trust in you, I do not need any proof. And this partially explains why today, let's say, I don't receive any proofs from my bank because my bank says to me, look, if you don't trust me, take your business elsewhere. And on the other side, my bank doesn't ask me to prove anything because it basically says, you shall give me all your data. And if you want me to execute something for you, just ask and I will decide. Okay. So in the conventional world, often we are assuming trust, or if we don't assume trust, if we don't trust our counterparty, usually a big corporation, then we're asked to find some other party that is also large and we should trust. And hence you don't see these proofs in the conventional world. But in blockchain, you see them a lot because blockchain is all about integrity. It is technology that delivers integrity, delivers us knowing that the right thing is being done, even when we're not watching. So as a technology, at its core, ZK delivers integrity. It also does so in a way that preserves privacy. So what does this mean? Famously, when people talk about zero knowledge proofs, what they mean is that I can prove to you, for instance, that I own a certain amount of Bitcoins without you knowing anything, well, without you having any trust assumptions about me. And still, I can prove it to you in a way that you will learn nothing beyond the claim that I just made. So the proof, the sequence of bits or the phrases I will make, the interaction between us, at the end of it you will have learned nothing new beyond my claim that I own, let's say, at least one Bitcoin. You won't know which Bitcoin it is. You won't know when I had it first and how I got it. You will just know that. So that's one thing that ZK delivers. And the other thing that ZK delivers, which is often, not noticed as much, is scale. Because to prove integrity of the operation of, let's say, the whole banking system in the US for a day is something that you can verify its integrity using a ZK proof in less than a second on a smartphone. Let me say it again. If you were to ask all the banks of the US to prove that every transaction that they did throughout 24 hours was done with integrity, and take the combined number of transactions and ask, can you verify the integrity of this thing? So you can on your smartphone, and your smartphone would consume no more than 1 second to verify this claim. So basically what you have is an exponential compression of computation, right? You can ask a counterparty to generate a proof that they operated with integrity, and they can generate a proof. And this proof will be verified by you in a time that is exponentially smaller than the amount of transactions or computation that your counterparty has done. And this is truly, in my view, the more surprising and useful aspect of ZK. So the famous blockchain trilemma says that, you want decentralization, which is this broadness that everyone can join and do so on simple means. You want scalability, which means you want to reach the level of, the number of transactions per second that Visa offers, or or the NASDAQ operates with. And you want security. You want this thing to be safe, to have finality, to know. I would replace security with integrity, knowing that the right thing is being done. And the trilemma says that you can have two of the three. So you can lose scalability, and then you have something like Bitcoin that is definitely decentralized and secure. You can lose security, that's actually very easy, and then or integrity, and then you can have something that is decentralized and scalable, like like the internet. So the internet is decentralized and scalable, but it doesn't quite have integrity. You can't trust it to just by itself operate, maintain money. Or you can have scalability and security, but you don't have decentralization. So this is the way most of the financial system works, right? It has a lot of integrity because you assume it has. There's like a big centralized server, and you have the nation states, putting laws into place and regulating these industries, and you have large scale, but then you don't have broadness or decentralization. So where ZK helps essentially is that it allows you decentralization and security, and it solves for scalability. And the way it does so is that it says, well, suppose you have something that is decentralized and secure, like Bitcoin or Ethereum, right? We have already achieved that, right? Bitcoin and Ethereum, each one of them is decentralized, and it is secure. It does operate with integrity. In fact, right, each one of them has been dealing with transactions that are in the billions and trillions of dollars. And by and large, society agrees that it does so with integrity, each one of these systems. But they don't have good scale. The TPS, the transactions per second of Bitcoin, is less than 10. Ethereum, I think it's less than 20 or so, whereas Visa processes per day probably 10,000 transactions and more. And Alipay does, probably close to 1 million. So they don't have scalability. Well, where ZK helps is that as long as you use your blockchain, this thing that is decentralized and has good integrity, to run ZK verifiers, you can actually assert the integrity of all of Visa's transactions and all of Alipay's transactions in a very seamless way. And this is not just something that theoretically can be done. This is something that, Starkware was the first to show, but everyone's doing today. So we are using the blockchain in order to run verifiers, system that verify the integrity of vast amounts of computation that are done outside of the blockchain, and you don't need to assume anything about the integrity of those external parties, because the integrity of the math, of the Stark math, assures you of that. So let me dive a little bit deeper into that. So here's a beautiful paper that is one of the very first papers on the topic. Not the very first, but one of the very first. It's a paper by Lassi Babai, Lance Fortnow, Leonid Levin, and Mario Segedi from 1992. And it's a very important paper in theoretical computer science. But I just want to quote one sentence from it that I enlarged here. So they say in this setup, a single reliable PC, right? This is in the world of 1992. Today, you would probably replace it with a single smartphone. Can monitor the operation of a herd of supercomputers with powerful but unreliable software and untested hardware. So let me say it again. They found a way in which you can have a smartphone monitor and enforce integrity on a vast amount of supercomputers where you have no assumptions at all, no assumptions about the software or the hardware running them. The only assumption you need is that your single PC or your smartphone or the blockchain that you trust operates with integrity. So, right, you have this point of reference, this very weak thing that suddenly can enforce integrity on any external operator, no matter at what scale it runs. So this is absolutely
But Ellie,
mind-blowing.
if I could interrupt and just put an economist's perspective here, you haven't explicitly mentioned a cost. And the costs are certainly there. Implicit, I think, maybe in your sort of the three legs of your trilemma, probably scalability. Where do you see, and even this checking computations and polyalgorithmic time, uh, the cost, the low cost, as I understand your approach, comes in the checking,
Yes.
but the setup so that somebody can do that checking is not necessarily low cost. Is that fair?
Yes, it's a terrific observation, and you are 100% correct. What happens is that the verification is exponentially small or logarithmic in the amount of computations. Okay. But the cost of producing a proof that you can then verify is super linear. It is more work than just running the naive computation. Now, it and you could think of it as, let's say, 100x more expensive, just to have some ballpark. So, but the beautiful thing is, and here it really you can break this down into numbers and costs, right? So what you need is you're saying to anyone who wants to operate, process, let's say, a lot of transactions, you say to them, look, well, first of all, let's compare it to the current system. I think that Ethereum probably has 100,000 or so nodes that each one of them verifies each transaction. Let's say it's 100,000. Bitcoin probably has more, let's say a million. So the current system is that each and every transaction is processed by each and every node in this decentralized network. So it's going to be 100,000 to a million repetitions of this naive computation. Now we have a technology where one computer that you make no assumptions about is going to run 100x more to generate a proof. But now the rest of the network, these 100,000 or a million nodes, have to run a million x less computation. Not 100x less, but like a huge, like a logarithmic, because I can give even the math numbers. The time to generate a computation, sorry, generate a proof, is what's called quasi-linear, which means it is n times log n. So log is usually, let's say, 30, or it's less than 100 in all practical terms. So it's like less than, for all the computations in the universe, is, let's say, less than 100 times x. So that's how I came to the 100 times more expensive. But the amount of computation needed to verify it looks like log of n, which is around, let's say, 30. So instead of each computer doing, let's say, let's take a billion steps. I'm probably confusing you all with numbers. Let's suppose that verifying transactions takes 1 billion steps. So in the conventional system of, let's say, Bitcoin or Ethereum, you have, let's take Ethereum, you have a million computers, each one of them doing a billion steps, right? So that's a million times a billion. That's the total cost on all of Bitcoin. Whereas using our system, ZK Starks, you have one computer doing 100 billion steps, but each other computer doing 100 steps. So you have 100 times billion plus 100 million. So you have 100 billion plus 100 million. It is less than 101 billion. And that is vastly less than a million times a billion, which was the previous thing. I'm probably lost a lot of you, but cost-wise, over the whole system, it turns out to be extremely efficient. One party does 100x more computation, but then a million computers, each one of them does a million x less computation.
Now, that's a very persuasive example as far as total cost goes, but it then seems like maybe that one computer is a bottleneck or a gateway or a centralized control over who can participate. Isn't that localization of that one large cost in a design philosophy,
Yeah,
doesn't that run contrary to the breadth goal of Bitcoin?
amazing question. So, two answers. First of all, when you design the network, let's say this layer two like Starknet, you get to decide, do you limit the production of proofs to only one party, or do you decentralize that as well? And you say, and by the way, we are of course going to the second solution, which is you decentralize it, which means in our case it's a proof of stake kind of
Hmm.
system. So you stake Starknet tokens, and then at some point it is your turn to either do it yourself or offer it to someone else to say, okay, I'm going to generate a proof for this thing. So you could totally decentralize the beauty. Look at, if you look at the sentence at the bottom, right? The party generating the proof is this supercomputer with powerful but unreliable software and untested hardware. The beautiful thing is that you actually don't care who it is, right? You could let anyone run it. So you could also decentralize it, right? As long as you have the verifier run on chain, anyone can do it. And in particular, Starknet, this is where we're heading towards. Now, there are settings which are also extremely interesting in which, let's say, a bank wants to come and say, you know what, I would like to operate on a blockchain. I want to impose the integrity of the blockchain and make assertions to my clients that will be upheld not by me, but by all of society through the blockchain. And it is still, I think, a dramatic improvement on the current state of affairs. And then, yes, this bank will run a prover. It will be the only party running it, but it will achieve both privacy for its customers and put itself under the yoke of integrity of the blockchain. So it is even in that case still meaningful.
Provisionally, I'll certainly accept that answer. I think it's going to be something we'll want to come back to, though. But for the time being, that's great.
Okay, terrific.
Back to 1992.
Good. So now I'm going to inflict a little bit of math on you, or like give you, I don't know, feeling for the math. Like, how does this magic happen? How is it that a smartphone can know the full integrity of, Bank of America's operations for a day? It like seems unreasonable. And it is quite amazing. So before that, let me just say that what I and my students and collaborators did, which led to basically ZK Starks, was this thing in 1992 was impractical. It is what you could call in theoretical computer science, we like to speak of galactic algorithms. So this is an algorithm that asymptotically, as the size of the problem approaches infinity, it at some point becomes meaningful to use it. But if you would try to implement this paper from 1992, you would get a system in which you don't have enough atoms in the universe to reach to, a computation in which you're better off using this system than just naively verifying everything. And basically, what I did in my academic mathematical research was to make the impractical practical and take things that were, you could now generate them on a laptop in a few minutes rather than using all the atoms in the universe. But we deliver the same thing. So how does this work? So here's a claim that you would like to give to the outside world, and you would like to know that it has been done, or this claim represents a computation that was done with integrity. Someone would like to say, well, starting, this could be, again, Bank of America. So it says, when we started our trading this morning, the state of the system was X, and we processed 1 million transactions, and we processed them by a well-known program, P. And at the end of the day, when we closed shop, the state of all the accounts is now represented by Y. Okay? You would like to know that this is done with integrity, meaning that if you would have seen each and every one of these transactions and followed the program P and processed them, you would have reached from state X to state Y. So now, what this beautiful math does is it converts each such statement into something that is like a Sudoku-like set of constraints, like a puzzle that is implied by the statement being proved. So once you have X, Y, the starting state, the end state, the program, and the number of transactions, you get this like big, nice Sudoku puzzle. And it has a few numbers filled in that relate to X, Y, and P, and the number of transactions. And now, if you want to prove the statement is being correct, you need to just fill a solution. And then there's a prover, the party that does the computation, that submits a solution. And then what the verifier does is it tosses some, dice, throws some dice, and selects one constraint from the Sudoku kind of constraints and just checks it. And if this constraint is okay, then it says, you know what, I'm convinced this was done with integrity. And otherwise, it rejects it.
So and that PCP is probabilistically complete proofs?
Checkable proof.
Checkable
It
proofs.
Is, yes. This is something that predates my work. It comes from the 90s, and it is a precursor of Stark, which is what, I co-invented. Right. So this is the way this was done. And here's the magic, or actually all of this is math. So first of all, to sample a constraint and know whether it's right or wrong after you read the answers, you only need an exponentially small time. You don't need computation time that is like 1 million transactions. You need something that's like, 5 transactions. So you can do everything very cheaply. The second thing is that if the party, the bank has operated with integrity, it can generate a proof that will satisfy 100% of the transactions, of these constraints. And the most surprising and hard to prove aspect is that if the statement is false, then no matter how you fill in the red numbers, no more than 1% of the constraints will be satisfied, which means that if you sample one with probability 99%, the verifier is going to say, wait, there's a problem. I can't accept it. And if you repeat this and take 10 repetitions of this test, then the probability is even smaller. So this is really the way you can now scale, because you basically ask these parties to generate a proof. And in order to accept the claim, you just test it using this method. So this is the PCP. And basically a Stark, the only difference is that after the prover submits a solution, we have another round of this thing. There's a little, there's a new puzzle that's related to the first puzzle. And now you have to fill that in, and we repeat it a few times. And then there's this sort of, let's say, 3-dimensional kind of constraint that can look into all, 3 of these Sudoku puzzles. And based on it, you do it. And it turns out that if you have this thing, you get if you allow this repetition, you get much more efficient proving time and verification time and resilience. So
now, Ellie, we have about 10 minutes before your hard stop time. So I'd like to leave about 5 for questions at the end. So go ahead.
Perfect. So I think I'm pretty much done, because this is like a little bit of the tasting of the math. So we take statements about general computation. We post the statements and the proofs onto the blockchain, but the proving is done on some big computer, no trust assumptions about it. And now you can go back to this trilemma and use the decentralized and secure blockchain like Ethereum and Bitcoin in order to verify proofs, and you solve the scalability problem. And that's basically what we did.
Thank
So
you. And
happy to answer questions.
we have a couple of questions in the Q&A. One are there any, this is from Olga Klein, who asks, are there any disadvantages of ZK rollups compared to the optimistic rollups? Any disadvantages?
Yeah, there are. So definitely. So okay, I'm assuming the listeners have heard about optimistic rollups. The very nice thing about optimistic rollups is that actually, um, so remember I said that the prover needs to run 100x more in order to generate the proof, right? With an optimistic rollup, as long as you're in the optimistic case, there's no overhead at all, right? Because um, well, actually, it gets. You don't need to generate these proofs. And if you look at the blockchain effect, right? We on Starknet, with every few hours or minutes, we post a new proof, and this proof goes to Ethereum, and Ethereum needs to verify it. If you go to an optimistic rollup system, most of the time there's only the new state of the system and no proof at all, because in an optimistic rollup, basically, unless someone throws a flag and raises an arbitration, the chain, the sort of this thing that is right, the decentralized and secure network doesn't need to do anything. So that's the big advantage of optimistic rollups on ZK rollups. But yeah, so but there are severe disadvantages of using this less costly way, which is basically if you're an end user and let's suppose you're willing to trust the blockchain, but now what do you do about these operators of the optimistic rollup? Well, right, in the ZK rollup, you don't have to have any assumptions, right? As you read in the sentence below, you can
Mm-hmm.
monitor the operation of a herd of supercomputers, but no assumptions about their integrity. With an optimistic rollup, either you have to verify everything that you're doing, and this literally means that now you're just running a node just like a blockchain requires you to, but just at a much higher scale. Or else you have to trust something about the economics of these watchtowers. But actually, when you think about these economics, I don't think they make a whole lot of sense because like most of the time, no one's going to be cheating. So these watchtowers don't have that much of an incentive to actually be watching. And then how do you really know that they will be watching when someone is putting a fraudulent state change there? So you really are sort of stuck in this situation where you need to run something on your own.
I'm
Um,
glad you used the word incentives there, and that's obviously a very important part of the whole picture. What are the incentives for verification? You've told us that it's first, it's very low cost and simple, but exactly for that reason, is it possible? So in finance, we have a history of market efficiency. And it was an article of faith for many years that all users in the market would optimally process information and all the information would get into the prices. And we all believed that until Sandy Grossman said, well, when you think about it, these informationally efficient markets are impossible. It's costly to verify. Maybe the cost is low, but if everybody believed it, nobody is going to verify.
So the way the ZK rollups deal with this is that they basically put the verifier as a smart contract on Ethereum and basically say you cannot update the state of the rollup unless a proof has been verified that this
Yeah.
is legitimate. So now there is a cost, of course. There's several costs. One is the what we call the L1 cost, the cost of the Ethereum cost of verifying, running the verifier.
Mhm.
And this cost is shared by everyone who's paying fees on the layer two. Part of those fees go towards paying the L1 for verifying this. And there's also L2 fees, which are the cloud fees. Someone's going to run 100x more in order to generate these proofs. So yes, those fees will go to provers, and there are fees that are collected and paid to layer one. So yes, there are costs and they are paid. Now
Okay.
it's very interesting the
But the
comparison because
verification does take place.
yes, it does take place.
Yes.
And here's an interesting thing. So right now, for instance, Starknet has the lowest cost verification. It's 15x cheaper than Arbitrum, for instance, and I think even more cheap than Base. So it's like, 10x or so. And you can ask, why is it cheaper? Well, the reason is because you have this extra proof. Well, one thing that is necessary on optimistic rollups is you need, in order to allow this arbitration, you need all of the auxiliary data, the witness, to appear on chain. And that also has a cost so that someone can arbitrate it. Now, with ZK rollups, you don't need that. So
Hmm.
actually, it's more efficient to use the ZK rollups. And even this is even true in the world of blobs. The whole reason for introducing blobs was exactly to have a place for these witnesses to be put in order to help the optimistic rollups. So from the ZK rollups point of view, we would love for all blobs to be removed because then, well, the optimistic rollups would actually be in a world of pain because they would need to put so much information on layer one and pay for it, whereas the ZK rollups don't need to put that information.
And I'm going to call this a final question, but really it's a synthesis of two questions addressing, and this is not, I think, specific to Starknet, but the fragmentation between L2s and L1s. They are competitors to some extent.
Yes.
And how do you see this competition evolving? Could most meaningful activity move to the L2s? If that happens, will there be enough to support the L1 ecosystem? How do you see that interplay?
So the short answer is I don't know. And yes, there is competition between the L2s, there's competition with the L1, there's competition between various L1s, between Bitcoin, Ethereum, Solana. And we don't know the final answer. To me, I think the final answer is no one in no chain in blockchain has really yet found global product market fit, right? None of them, not even Bitcoin, with all my love and respect for Bitcoin, right? Very few people in the world use Bitcoin even on a monthly basis. Maybe a lot of people already now have exposure through an ETF, but that's not interesting to me. Um, so the true answer is that I have no idea how this will play out in the end. I have no idea. Um, yeah, so I don't really know, but yes, these are competitions. I think when I think of this integrity web, I imagine, the best analogy is that I have is maybe some mixture between the World Wide Web and then just the world of the economy and all of its networks. So there will be some standards like, I don't know, Swift or the way that, I don't know, the ACH system, however it works in the US, and you'll have like these core protocols, but
Hmm.
then there'll be like a lot of different things that are connected. Users will probably a lot of this will be abstracted away just because that's what users want. Um, so maybe something like that, but honestly, I don't know yet.
That sounds like a perfect answer, a speculative answer on which to leave our audience. Ellie, thank you very much for spending time with us this morning.
Thank you. Thank you,
And
Professor
it
Hasbrouck.
was extremely stimulating.